Okay, hi everyone. My name is Leon. I am a DevRel engineer at GNOland. And today I'll be talking about how to build a dApp in Go and generally speaking, how to explore Web3 ecosystems as something new. Just a little bit about me. So again, my name is Leon, or Lav in Serbian. I've been working in Web3 for about 3 years now. I've attended quite a few Web3 conferences and also have won prizes at a few Web3 hackathons. And my current official position is a developer relations engineer at GNOland. This is my GitHub. You can check it out there. And I'll be here until the end of the seminar. So if you do have any questions, any topics you want to discuss, anything, let me know. Okay, let's get started. So quickly, today's agenda is just a few points. So first, I'm going to tell you just a little bit about why you should explore Web3 ecosystems, why you shouldn't just sit in one ecosystem, like, for example, just learn about Ethereum or Solidity or EVM or whatever. Then I'll give you a very brief introduction to Golang, which is a Web2 language. Some of you probably have heard of it by now. And then I'll give you an introduction in what GNOland is and what GNO is. Then after that, we'll do a hands-on part, where we're going to build a minimal Twitter clone with GNO. So GNO is a language which you can use to build smart contract applications, just like Solidity, except on a different chain, and you'll see soon. And then if there's anybody who is very quick at developing and wants to do more, you guys can call me later, and I can give you a bonus task if you might want to do it. It's basically building a small AMM, an automatic market maker in GNO. So if anybody does want to do that, let me know. Okay, awesome. So the point of this workshop, it is to teach you about what I do and what development is in blockchain, etc. But it's also essentially an idea. Actually, it's a workshop to test your skills, right? So the idea is you guys have learned about something in the previous couple of days. So you've learned a little bit about Ethereum, about blockchains. You've learned what a block is, what a transaction is. The idea is that that kind of knowledge that you learned can usually be applied across the board. So there's many different technologies that apply for blockchains. So, for example, you have Ethereum, you have maybe Solana, Cosmos, all of these technologies that are essentially blockchain systems. And the idea is that you should be able to use the base knowledge that you've built so far to quickly learn and explore new ecosystems. So the idea today is I'm kind of going to put you in the fire, so you guys are going to have to try to learn on your own a little bit. So I'll give you some hints, obviously, and there is something to follow. So it's not just, hey, just learn. I want you guys to try to figure stuff on your own, figure out stuff on your own, read the documentation, etc., etc. But I'll be here. You can ask me anything if you need any help. But it's mostly going to be you guys. So you're going to just clack away at it. Okay, cool. So first, why would you want to explore Web3 ecosystems? So why would you not just want to sit in Ethereum? The idea is kind of similar to normal IT, well, because this is kind of, right, it's a sub-branch of IT, blockchain, but IT develops very quickly. So the idea is that if you do not constantly learn and constantly develop and grow your skill set, you will get left behind, unfortunately. Not always. Sometimes you can clack away at PHP. But it's good to learn, and the brain likes to learn and keeps you young and everything. So all in all, it's a good thing. And development is really cool because of that. You get to learn all the time. And then in case of blockchain and Web3, even more so, sometimes stuff happens on a weekly basis. Like technologies just pop out, and there's a lot of new things, and people are experimenting, and blockchain is very new, essentially. Well, Ethereum is, 10 years old, which is not too much, really. And then everything else that came after is even younger. So stuff is developing really quickly, and people are experimenting. And that's also one of the really cool things about blockchain, is that you get to be part of this creation part, right? So you can actually try to create new things instead of just using old things. That's something that I really like about blockchains. So, okay. there's different paradigms, right? Different ways of doing things. You have Ethereum, which has EVM and Solidity, and there's also like Viper and some other languages, but basically EVM, right? For example, you have Solana, Near Protocol. These blockchains use Rust for their smart contracts. You have Cosmos, which is kind of like a hub. It allows you to connect multiple different chains together via a protocol called IBC, and et cetera, et cetera. And opportunities lie everywhere. Why did I write this? Basically because a lot of these ecosystems are new, as I explained. And the idea is that companies that are building them, or people that are building them, want other people to see them. Right? They want their projects to gain popularity for X reasons. And there's a lot of opportunities in Web3 for this, especially if you're young and you want to try to learn development and learn blockchain development specifically. There's a lot of cool opportunities which you as a student can utilize. You can travel, you can earn money, you can hack, you can meet people. It's really amazing. So it's very nice to actually explore stuff. Okay, cool. So next up, I'll just give you a brief overview into what Golang is. So Golang, again, is the Web2 language that I mentioned before. So Golang was launched way back in 2009. It is a type-safe language, so it has types. And it's garbage collected, so if something isn't referenced anymore, it's going to get automatically cleaned. So Golang was actually built on top, or as, well, like an upgrade to C. So how many of you guys have actually used C before, like directly? Okay, most of you. Nice. So the idea is like, if you know C, Go is just like nicer because it has pointers, it has all these things, quite powerful, but it doesn't allow you to shoot yourself in the foot that easily. Yes, and it's relatively straightforward to learn. So if you do know C or any C-like language, Go is very, very easy to learn. And the whole point of today's workshop is that you guys are going to try to learn it through the workshop, right? And this is a cool resource. You might want to take a picture of this or like open it up. So this is learnxandYminutes.com. It's like a website where there's a big list of languages, and the idea is it gives you a short overview of what a language syntax is. For example, for Go, you go there and then you'll be able to see like the comments are written like this is how you do this is how you do this, et cetera, et cetera. So could be useful for you guys during this workshop. So like write that down and yeah, maybe it's going to be good. Okay, cool. So let me actually sit down and open up a terminal and an editor. So okay, so I have a clean project here. I'm just going to make a test folder. Doesn't really matter. And let me know if you guys can see if it's big enough. Okay, so I just want to write a very, very simple Go program, and I just want to show you like the basic syntax that it has. So as you guys know, so this is a clear directory. If I do Go, I have something popping up. So Go is installed on my machine. So you can start creating a Go program by doing go mod init and then giving it the name. It's going to initialize a module. And basically modules are like packages, like basically organizational units of Go code. So now what you can do is you can create a file, for example, counter.go. And it's Go syntax. And I'm using VS Code. You can use anything else, although later it will be easier to use VS Code, but it's OK. And what I'm going to do first is I'm going to define a package name at the top. So the idea with this is, I'm going to define it as main. So the idea is this package is called main, and it will have a main function, and everything else will know it as the main package. So that's what this package main means. So this is how you define a function. It has a main function, just like C does. That's like the entry point to the program. And I can do fmt.println, for example. FMT is a standard library. So Go has a list of standard libraries, standard packages, rather, which you can use readily available to essentially easier development. So let me import. So you can do imports like this, and then you can do FMT. And then FMT println, let's say hello world, right? So how you run this is you can do two things. Essentially, Go is compiled just like C. So what you can do is you can compile it somehow. But the other way to do it, oh, well, you can do go build, okay. Go build dot. So if I do go build dot, I'm going to get a main executable file. It's a binary. So then I can do dot/main, and it's going to say hello world. So that's one way. So it was compiled, and then it was executed. And then the other way you can do it is you can do go run, which is going to build, compile, assemble, whatever it needs to do, and then run it automatically. So this is like a shorthand, let's say. Okay, so that's like the very simple syntax of Go. It's doesn't look too different, I hope. What do you guys think? Like, is it complicated? Okay. Okay, so I do want to teach you a couple of other things before we dive. Do you guys still see in the back? Is it okay?
No.
Yes? No?
Yes.
Yes? Okay. Okay, cool. So let's define a variable. Let's say message can be hello world. So what you have in Go is you have this, oh, I'll zoom in. So you have this thing, it's called, I don't know how it's called, but this basically combines a declaration and an initialization, yes. And the idea is that essentially this will infer the message. This will infer the type of the variable. So in this case, it's going to know that it's a string, but you can also do var, msg1, whatever, string, if you want to ring, if you want to be explicit about it, right? And then you can say, you can give it here, you can put it here, and then it's going to do the same thing, right? Okay, and then another thing that I want to show you is that it also has pointers. So just like Go, just like C, I'm sorry, you can create a pointer, which can be a address of MSG. And then what I can do is I can say print the pointer and print the message, or let's do this. So what's this going to print?
An address and
Yeah.
address and
Address and, yes, in the word.
Can you please show one more time how you initially ran the program?
Yes. So you have two options. One option is to do go build, and then give it the directory, and it's going to create a binary.
But it says go.modify not found in current directory.
Are you in the correct directory? So in this directory, I have go mod, and the binary that I can remove this binary, but.
You maybe went a bit too quickly to the mod init file.
Right. So possibly. Do you have this? Do you have this file? Okay, so what you can do is, let me try again. In this case, you can actually just do go mod init main. Okay, and then when you do that, it's going to create this go mod file that's going to allow you to actually build and run this. Is it okay? Maybe. You guys don't have to do this specific thing. I'm just showing you some basic stuff about Go. But okay, so we said that we defined a string, and then we defined the pointer to that string, and the pointer is the address of this variable at top. So if I print this, it's going to print out the address, and then this is going to dereference that address, and it's going to print the value at the address. So I can do go run dot, and it's going to say, okay, this is where hello world is in memory, right? All right, awesome.
Maybe it's valuable to note, sorry for interrupting. These variables do have types. He mentioned that Go is strongly typed. So even though he didn't say that this is a string, Go will make sure that MSG is a string. It's not like JavaScript where you can just do anything with variables.
Yep.
It's just that it was implied. And you can be explicit if you want to.
Yes, like this. So this is like explicit, but the shorthand for this is MSG column equals and then whatever.
In
right.
practice, you almost never actually do the thing you have there, but
yeah. Okay, and then let me see. I wanted to show you one more thing. So functions can return things, right? Obviously. So you can return a string. You can return multiple strings as well. So you can return many different. You can have multiple return values. That's what I'm trying to say. And there's also an error type, which is used for erroring, right? So yeah, that's like the gist of it. So as you can see, like it's not too complicated if you're familiar with how C or C-like languages work. Generally speaking, this is relatively simple syntax, right? One more thing that Go has that we'll use is it's called slices. They're called slices. They're basically arrays, but they're expandable, so they can change size. And it's quite simple how you define them. It's just which you might expect from a C-like language, right? Okay, cool. So that's like the gist of it. I showed you this. So this learn X and Y. Let me just. Well, actually, I'm not going to go there, but you can go here and you can read a little bit more about the syntax. It's literally meant to give you a brief overview of how to do things in Go in like 5 to 10 minutes, right? Okay, cool. All right, off to the next section. So I want to give you just a brief overview of what GNOland is and what GNO is. So the company they come from. The idea is basically this. GNOland is a layer 1 blockchain. It's just like Ethereum. It's a blockchain, first of all. And then after that, it has its own virtual machine. And that virtual machine runs this language called GNO, just like the EVM runs Solidity or bytecode Solidity, whatever. But GNOland has a virtual machine called GNO VM, which runs the GNO language. And the idea with the GNO language and why I'm showing you Golang is GNO is basically identical in syntax with Go. So the idea is that if you already know Go, and a lot of people do know Go from the normal Web2 world, people who do know Go will just be able to come and just build stuff in GNO already because they know it, right? The idea is when you want to start blockchain development, you have to learn about all of these like concepts, and then you have to learn a new language, and people don't like to do that. So we created a language that's identical to an existing language that just allows you to write like immediately. It's created by the Cosmos co-founder, Jake Wan. And again, well, GNO it's an interpreted version of Golang. So instead of compiling, just like Go does, so Go compiles, GNO is interpreted. So it goes like, it has an AST, abstract syntax tree, and it kind of compiles and interprets at the same time. But that's not important. The point is, GNOland is at its testnet phase right now. So we just actually recently released a new testnet. I'm probably sure you guys have heard about the testnets in Ethereum, like Gurley, Sepolia, all these. The idea is that these testnets are meant to be used as test beds for your application, so you can deploy your application for free to these testnets and test it out and see if there's any bugs and try to improve it, et cetera, et cetera. So we just released a new testnet called Test4, and yeah, you'll be able to use it a little bit later. The websites which are going to be useful are GNOland, so gno.land, literally just like that. It's the homepage of the project, and then you have docs.gno.land, which is the documentation, which you'll also be using. Okay, cool. Sure, then that's it. Let's dive in. Let's get started. So go to this link, and it's going to bring you to a repository that I built. And we're just going to go through the initial phases together, and then I'm going to let you guys do your stuff. Just let me know when everybody's done going to this link. Everybody good? Are you guys on the link? Okay. All right. Let's see. So this is very simple. I hope you guys have Git. You guys have Git? Okay, good. Okay, so what you guys are going to do is clone this repository locally. And the idea is that we're going to be building this Twitter clone, right? So it's going to be very simple. It's not going to be complicated at all. It's just going to be like a post, and then somebody can post, and then somebody can upvote and downvote, and then some other stuff. But the idea is that what you guys are going to do is, after cloning this, you're going to get something like this. Zoom in. Okay? Let me know if you guys are done with the cloning. So just clone it anywhere locally, and it's going to be good. All right? Okay, so as you can see, this very plain README at the beginning says that there's multiple phases to this, and you can check out the phases folder to start. So let's just go into phase 1, and we're going to go through phase 1 together because it contains some installation again. The idea with this is, let me actually try to, okay, not that. Is it this? Yes, but I want to, okay, cool. So for this whole workshop part, right, you guys have to install GNU and GNU-key and some other tools, and I'm going to just give you a brief overview of what each one of them is, and I'll show you how to use them. One of the things that I also wanted to tell you is that if you're using VS Code, I assume some of you are, you can go to the extensions part, the extensions tab or whatever, and you can type in GNU-lang. And this is an extension for syntax highlighting for GNU. It's going to help you out a little bit when you develop. If you're using anything else, it's going to be a bit more difficult, but still it's going to be okay. And then obviously if you do need any help or if you have a bug or anything, just let me know and I'll help you out. Okay, so let's, is everybody at this point? Yes, no? Okay, cool. So let's just go through this together. You can follow along. So basically we're going to go to this website. This is the documentation. And it's just a very, very short overview of how to install GNU. So the idea is this. You need to have Git. Make, if you have make, great. If you don't have make, that's also fine. We'll be able to work around it. You guys have Go now, and this we'll see if you guys have, because sometimes this Go path is defined properly automatically, sometimes it's not. We'll figure it out along the way. But okay, so to do this, first of all, you can copy this command, and basically what you're going to do is you're going to clone another repository. This is the main GNU-land repository. So you can download it, and let me just, I mean, I have this installed already, obviously, but let me just do git clone, and then it's github.com/gnulang/gnu, and then you're going to clone it into GNU, and then you can go into the file, into the folder. If the Wi-Fi.
Where do we clone it?
You can clone it anywhere.
So it doesn't have to be in the
No, it doesn't have to be anywhere. Yeah, you can clone it anywhere you want. Because this is going to be used only for like installation, so you can sit anywhere, it doesn't matter. Yeah, the internet is very nice. Maybe I'll stop mine so that you guys can download. So once you do clone it, you should be able to see something like this. Is everybody still downloading? Yeah? Okay. Все? Ovo je Goland. Što ne vidiš? Pa ovo je što je klonirano. Dobro. Ali monorep, čekaj. Okay, so again, if we go to the docs page, right, and then you clone this repository, you can copy this command and you can paste it into your terminal. You should be able to get the monorepo. So is somebody still like downloading because of bad Wi-Fi? Yes? Yes? Okay. Anybody else? Okay. Yeah. Everything okay? Did you clone it? Yeah? Okay, cool. So when you open, so you're supposed to open the, oh, well, you can just go to the terminal, it doesn't really matter, and then just find the repository that you cloned, okay? So mine is desktop GNO, and then GNO again. So this is the repo, right, that we just cloned. So what you can do is now, bear with me, but let's do make install. Try to do this, and then if it doesn't work, let me know. If you don't have make. Okay, let's do something else then. Yes? Okay, is it an error? It's an error, right? No? Is there a green line that says install? No, okay, never mind. Okay, let's do this. So if you don't have make, we can go around that. So first of all, I'm in the main folder. Just follow me, okay? First go to gno.land, okay? And then here, you can do, let's see the make file. So the make file has a lot of things, and basically what you need to do is you need to do go install GNO key. This is what we want, okay? So this is one. This is directly through Go, okay? So let's try this. Does this work?
Where do we run that?
So it's the so in the repo that you cloned, you go to the gno.land folder, and then you do go install cmd GNO key. Okay. So most of you guys have managed to install through go install, right? Most of you, those who have Go working, right? Okay. Let's do another installation, because so make install essentially installs 3 tools. So if I do it on my laptop, you'll see that it installs 3 things. My bad. Here. It's going to say GNO key, GNO, and GNO dev. So these are the 3 tools that we need. And so we first just installed GNO key, right? So now we got to install GNO. So if you go back into the main folder, now you can go into the GNO VM folder. And then here you can do go build, or rather go install cmd GNO. So this is the second tool. Okay, so this is tool 2. I know that some of you guys' binaries are not working. It's okay. So just follow me just one more step, and then we'll fix the stuff that's broken, okay? So that was tool 2. That was GNO. And now the final tool that we need is we go to cd contributs, GNO dev. And in here we do, again, we do go install, and then you just do cmd GNO dev. So just do this, and then we'll fix the, you guys are getting like the unknown command error, that's okay. Just install this, and then I'll help you fix I'll help fix the other one, the other error. Okay, did you guys manage to install the GNO dev tool? The last thing that I showed? So this? Okay, so it's possible that some of you guys are getting, when you try to run either GNO, GNO dev, or GNO key, you get like unknown command error. So go to the top of this page, and then here, there's this thing. So it's part of the Go environment setup. So this is something that we have to deal with Go. Basically what it says is if the binary isn't seen by your terminal, that means that this go path / bin, so where the binaries are stored when they're installed by Go, your command line doesn't see it. So try to copy this. So you would export the Go path, and essentially the Go path is where Go lives, right? And then into the path variable, which contains all of the things that your terminal is reading, there you add the Go path and then /bin. So basically, these 2 commands should fix your issue. Try it, and we'll see how it goes. Okay?
So that's if our Go doesn't work at all?
Sorry?
That's it, Go doesn't work at all.
No. Let me see. So, this is the, we just finished installing the binary. So you have 3 binaries. The first binary is GNO. It's just like Go, right? That's the whole idea is, kind of copying what Go is doing. So the idea with GNO is that it's the binary that allows you to actually run code. So you can do GNO run just like you do Go run. You can do, for example, other things. If you check the help page, it's going to tell you exactly what you can do. You can do run. You can do GNO mod init, just like Go mod init, et cetera, et cetera. But I'm not going to get into details here. That's what GNO does. GNO key. Now GNO key is ignore this suggestion because I don't know how to turn it off actually. Whatever. Okay. So basically, what GNO key is. So far, I assume that you guys know what MetaMask is, right? MetaMask. Yes. No. Yes. Okay. Okay. MetaMask is a wallet, right? So a wallet is actually it's kind of a dumb name. It's not a wallet. It's actually a keychain. That's what it really is. What I mean by that is basically MetaMask stores your keys. So it's like a keychain, right? It's something that you hang your keys on. But people call it a wallet because it contains money, but it doesn't actually contain money because the tokens are contained on the blockchain, and the keys that you have in MetaMask allow you to use that money. Right? So the money is on the blockchain while the MetaMask is not a wallet, it's a keychain, but whatever. Point is, GNO key is something like MetaMask, just for GNO. So in the case of GNO land, we have a wallet that's a web wallet. It's called Adina. But for this workshop, we're not going to be using it. We're going to be using the CLI version. And this is kind of maybe weird for you guys because I don't know how often you use the command line tools inside of it. But when you develop with Go and with GNO, it's very common. So I'm going to show you just a quick way to create a key pair. And it's all written in this README, but to actually do this, you can do GNO key add, and this is going to add a new key pair. So you can give it a name, for example, my key or whatever, and then it's going to ask you for a passphrase. So it's like a password, just like when you open up MetaMask, it asks your password. So this is basically the same thing. What I do in this case is I just hit enter, so it doesn't really matter, and I missed it, so I'm going to do it again. So enter, enter. And what it does is it gives you an address, and then it gives you a mnemonic, right? So just like you have with MetaMask and other blockchain wallets, it's the same logic. You have this seed phrase, which is basically a seed, right? It's a seed for randomness from which you generate the address. And the generation algorithm in this case is called Batch32. It doesn't really matter. But the point is, whenever you have the same seed phrase, you can always derive the same address over and over. Right, so basically point is save this mnemonic, just like everybody else told you for MetaMask. For now, you can just copy it somewhere on your PC, but if you actually want to store it properly, write it down somewhere, store it somewhere offline, don't put it on your laptop, okay? But for now, it's okay. And obviously, don't use this one because it's public now, right? Okay, cool. So now you added a key pair. So now, just like you have created with MetaMask a key pair before, now you have a GNO key pair with GNO key. So in order to check what keys you have, GNO key actually has a lot of different subcommands that you can use, and basically one of them is GNO key list. And I have a ton of keys, as you can see, but basically the idea is this is the address. It's like the Ethereum address, the same thing, right? And then you have the pub key, which is like the public key. Actually, how this works is you have the seed phrase, and then you have a private key generated from it. And then from the private key, you generate a public key. And then from the public key, you generate an address. It's a misconception that an address is a public key. It's not. Usually it's not. Just so you know. But basically, address, more or less, the identity that you use on the blockchain. Okay? And then you should see a my key or whatever you named it here. Okay, awesome. So that's add, that's list. So these are the two commands that you're going to be using. And then there's some more, but we'll go over them later. 1 second. And then, okay, so that's GNO key. I explained GNO and GNO key. And now the final thing that I need to explain to you guys is what GNO dev is. So GNO dev is a all-in-one tool, let's say. And have you guys used Hardhat by any chance? Have you heard about it? No? Okay. It's okay, it's okay. All right, so basically what GNODev is a tool that allows you to very simply develop locally. So for example, in the case of Solidity, let's say, you would like go to Remix or go to some editor and then you would deploy stuff to some network, somewhere, whatever. GNODev allows you to run a local blockchain node. So it literally spins up a node which contains the virtual machine, contains everything that you need automatically for you. So you just run GNODev and it's like running a server, right? It's not gonna like end the command when you run it, it's gonna actually stay alive, right? So if I do GNODev, it's gonna say, hey, some accounts loaded, something happened, and then, okay, so node started. So this node is actually the GNOLand node. It's, if you've learned about blockchains, right? You have these nodes that are connected to each other. In this case, this is just one node that's living locally on my laptop and nobody's talking to it except me, right? And then that node is running the virtual machine that's going to run the code that we're going to write, et cetera, et cetera. And it's running this thing called GNOWeb. And this is another service that it's running. So that's why I said GNODev is like an all-in-one. It has a node, a blockchain node, and it has a web server. That's what GNOWeb is. GNOWeb is a server. It's like a small service that basically says, hey, node, I need some information about what's going on the blockchain. Can you give me this information? And then the node says, yeah, sure. And then it gives GNOWeb the information. And then basically, as you can see, here, the node is listening on localhost 26657. So this is where you would send your transactions, queries, etc. And then this is where GNOWeb lives. So GNOWeb is just a server that serves a front end for you to be able to see what's going on the blockchain. So if I click on this and open it up, you'll see that it's basically, well, if you have gone to gno.land, you would notice that it's kind of the same, right? So the point is gno.land is actually a GNOWeb server running somewhere. And this is local right now, okay? So what I'm trying to show you is that GNOWeb spun up on localhost 8888. And then it asked the node, hey, I need this specific path, which is our GNOLand home. Okay, so what does that mean? That basically means that the node was asked about something that's found on this path. So just like you guys have DNS, you know what DNS is? Right, like DNS, the domain name service, right? So like, for example, if you go to facebook.com, it's gonna route somewhere and then it's gonna find the server that says 196 point whatever, and that's where the machine lives, right? GNOLand kind of has a similar concept. In Ethereum, you guys learned that when you deploy a smart contract, you get an address back, and that's where your smart contract lives. In the case of GNOLand, it's a bit different because you decide the address, or well, actually not the address, you decide the path. So basically, every application, every smart contract, or we call them realms, but it's interchangeable. Basically, the idea is GNOLand allows you to define in advance where you want to deploy your smart contract, and then from there, you can actually just go to gno.land and then whatever the path you chose, and then it's going to pop up. So this specific thing you're looking at right now, this is actually a smart contract. And all of this data here, everything that's going on in here is actually on chain, on my local chain in this case, but in the case of gno.land, like on the web, it's actually a blockchain. And the idea is that, here you can do a lot of things, and one of the cool things about GNO is that actually everything you upload to GNOLand is open source. So in case of Ethereum, you have Solidity, you have Viper, you have, well, let's say Solidity and Viper, and then what happens is it gets compiled into bytecode that humans cannot really read, right? So the only way you can actually know something is happening on the Ethereum blockchain is if the developer specifically chooses to say, hey, this is the code, I published it and it's open now and everybody can read, et cetera, et cetera. In the case of GNOLand, it's by default. So nobody can upload bytecode. This is why we do interpretation, one of the big reasons. That's the idea. So the idea is, if you do go here and then you just click on source, you'll be able to actually see the GNO files that comprise this this smart contract. And then if you go to home, and then you'll be able to see. And this kind of looks like Go, right? I mean, kind of is Go, right? And then you have a bunch of things here, blah, blah, blah. But the point is, right, so that was the, I just gave you a brief overview of like what GNOdev does. And so GNOdev, again, GNOWeb, the web server, and then the node, and then they talk and they bring you this, right? Okay, cool. Okay, let's get started again. Okay, let's go. All right. So getting back to the README, right? So we installed all of the stuff that we needed. Great. And I also learned that this workshop is 4 hours instead of 3 hours. So we have time. Great. Okay, so cool. So the thing you want to do next is you go into this P1 folder, right, where you find this README. And here you'll find something that's maybe familiar to you. Like I already showed you how Go works with this. So it has like a Go mod, and then it has like a .go file. In the case of GNOME, it's a bit different, but it's quite similar, right? The whole idea is to kind of mimic what Go does. So in this case, it's GNOME mod, and it's .gnome. Okay? So if you go into GNOME mod, it's basically the same as the Go mod thing. So it just defines where this specific package will live. And in this case, it's going to live on gno.land /r/petnica/hello. Okay? So I'm just going to quickly explain what this all means. GNOland is like the root domain. So this is like the DNS, right? You have like a www.whatever, right? So something like that. So GNOland is basically an identifier that this app is going to live on a GNOland blockchain. Okay? Then you have something called R, or realms, as I maybe mentioned before. It's basically another word for smart contracts. So we call smart contracts realms. So it's a realm. Okay. What in this specific spot, it can be only P or R. Okay. So P stands for pure. And what does that mean? Basically, this means that anything that you upload to this specific, so these are like namespaces, right? Like you have specific namespaces. So anything you upload under P doesn't have any state. That's why it's pure. Just like in Ethereum, you have pure functions. They don't, I think they only return constants or something. So like the idea is it's pure. It doesn't contain any state. So it's only libraries. It's like functionality that you can reuse and reuse, and it doesn't store anything. Okay? That's what P is. And then R is where applications live, like smart contracts that have state, that have something that changes state, some functions, et cetera, et cetera. And then the idea is by using this is called the package path. It's like a path, right? The idea is if, for example, you have gno.land /p/demo/u fmt. So this is a package that exists, actually. And the idea is that by using this package path, this is like the identifier of the code, right? Just like I mentioned before. So in the case of libraries, you can import things using this. So for example, I don't know if you remember, but previously we had like in the Go file that I made, it was like fmt.println, and then it import fmt. So in this case, we can still import like FMT, we can import some things that are like that, but we can also import on-chain things, and this is what I'm talking about. So you can basically open up this file, and then this is something similar to Go, right? It looks basically exactly like Go. And it has a couple of things. It has like this render function, this update message function, et cetera, et cetera. But what I want to actually tell you is, you see, it basically looks the same as Go. This can actually run as a Go code, right? So the idea is you can also import classic stuff. One of the really important things that you want to import, and you will want to import, not in this case, but it's the std package. And this is a package that is specific to GNOME. And this package is very important because it contains the functions that give you the blockchain functionality. So for example, I don't know if you remember, but in Ethereum, we have this message object where you do message.value, message.sender, message.etc. And it gives you, for example, the transaction caller. It gives you the Ethereum's ETH sent with the transaction, etc. std, in this case, does similar things. So you can do, you can get the caller, you can get the amount of coins sent with the transaction, etc. So that's a package to just keep an eye out on. you'll be using it. And then in the case of specifically FMT I mentioned, so FMT was the package that, this is format by the way, FMT is format, I think. The idea is that FMT in Go allows you to print stuff to the standard output, and you can format strings and you can do a lot of these things. But in case of GNU, FMT doesn't exist. And it doesn't exist for one reason. Maybe some of you will know, will understand why. Maybe not, but I'll mention it anyway. The idea is that blockchains are deterministic, right? And that means that if you take the history of blockchains, they will always be the same throughout history. So you have each point in time, each block is always the same when you replay it, right? FMT as a package uses something called reflection. Does anybody know what reflection is? Okay. Point is, reflection is non-deterministic, and that's why you cannot have it. Okay, cool. So in that case, because we don't have FMT, we do have something else, and that something else is found on gnu.lan/p/demo/ufmt. And this U here is actually micro. So it's like a small version of FMT. That's the idea. So this is something that we built instead of FMT. Okay? And then what FMT allows you to do is, for example, you can say, whatever, message 1, doesn't really matter, and I'll say ufmt dot sprintf, and sprintf means return a string and print it and format it. So S is string to return a string, print is printing, and then F will allow you to format. And basically what you can do here is you can do something like in C, right? You guys know printf in C. It's kind of similar. So the idea is you can say this is a string, and then you can give it a string, and then you can give it a number, etc. And then you can say my string, and then you can say 1, 2, 3, right? And then this is going to return a new string that's going to contain this, but these identifiers are going to be replaced with the arguments in the back, right? But what I'm trying to demonstrate here is basically the fact that you can import things with this, okay? Yep.
What's the difference between importing it inside the script or inside the mod file?
Right. Okay. So the question is, what is the difference between importing it here or in the GNU mod file? Is that right? Okay. So the GNU mod file is actually just a file that stores the dependencies. So the idea is when you import it in code, then you can say, okay, ufmt dot, and then use the package. And in the case of GNU mod in here, you don't actually import it here. You don't really do this. This file is actually supposed to just store what your code is using. So just like a reference in some way. So if you actually, this is a good point. 1 sec. So if you go to, 1 second. So if you go here, so I go into P1. If I do GNU mod tidy, tidy is a command that also exists in Go. Basically, it like tidies up the mod file. So if I do this and then check it, you'll see that, hey, this code, this hello code, it requires this package. That's what GNU mod is for, right? It allows you to give, it allows you to list out the dependencies that you have, and that's the same for Go. Like if you take a look at the Go mod file, is going to have like a ton of things that it installed for your app to be able to work, right? Okay, cool. But point is, you have 2 types of things you can import. One thing is the packages that live on chain. So the idea is that this package exists on the chain somewhere, and the idea is that instead of having to always rewrite all of these packages and functionalities and everything, redeploy, in Ethereum you have to always redeploy things, usually. In this case, this already lives on chain. You can just import it from the chain into your app. It works. Okay, cool. Let's actually try to do something with this app. So go back to the initial state, and let's actually just close out GNU dev. Sorry. So this was we ran it just to test it. So now it's not live. It's not running, right? We're in P1, and then what I want to do is GNU dev dot. So what dot is going to do is basically it's going to take the package that exists on that specific path, and I gave it the current path, right? And it's going to take the code there. It's going to think of it as a smart contract, and it's going to automatically publish it to the local blockchain. That's what it does. So if I do this, it's going to say a couple of things. It's going to say, hey, I loaded this path, and I use this address to deploy. Okay? So the cool thing about this is that then, once you do this, and is this working for everyone, by the way? More or less? Okay, cool. So if you go back to the README and go down, here you can actually click on this link, and you have Hello World, okay? And this is actually the live application that you're seeing in the code that we wrote, right? Or which was written. So basically the idea is you can click on source, and then you can click on hello, and then you'll see the same stuff, right? So this is an actual app that's living on the local blockchain. Now the cool thing about GNODev is that instead of having, like when you have a blockchain, usually you have to redeploy things to be able to incrementally move the functionality further, et cetera, et cetera. In this case, GNODev, because it's local, it can just rerun stuff. So the idea is if I go back to code here, and I do, for example, Petnica, and I save, GNODev is actually very smart, and it says, oh, I noticed you changed something, I'm going to reload. And then if we go back to the app, it changed, right? So it's actually changing the state, it's replaying stuff, which is really cool. Okay, so now to give you a basic overview of how smart contracts work, so this is actually a smart contract. You see how you have that variable at top called message? Just like you have in Solidity, when you define something like that at the top level, in Solidity you do contract, whatever, and then you open up the curly braces, and then you have the main thing where you like define the stuff at top, you define the functions, you define events, you define all these things. Just imagine that contract stuff just doesn't exist for us. So anything you define up top, it's the storage, right? That's the idea. So this means that message will be persisted to the storage of the virtual machine. Then function init. This is a Go specific thing again, but init is like the constructor in Solidity. So basically this happens once the package is deployed and GNODev deploys, right? So it reads the path that we gave it, and then it deploys the contract, and then init happens, and then that's where this specific value is set to the message variable. Okay. Cool, so it's reloading. We can go back to world, let's say. It's going to reload again. It says, hey, I'm reloading. I noticed you changed something, and then it's going to go back to world. Okay, cool. So now, there's another thing that I need to show you. And that is basically this help page here. So if you go to help, this page is basically going to give you some pre-made commands, which you can just copy-paste into your terminal and actually run stuff. So if you take a look at the code here, we have this update message function, and that message, that function updates the message, right? It's kind of obvious. So the idea is any function in Go and consequently in GNO that starts with a capital letter. So this is a big U, right? And then you have init, which starts with a small u. Any function that starts with a big U can be called as a public function. So that's what it is. They're literally called exported and unexported functions. So just like in Solidity, you have public, private, internal, virtual, all of these keywords. In Go, it's just small or big letter. Okay? So this function is a public function. And this is what's going to show up on this help page. So this, essentially, this help page gives you the message, gives you the function, and then it gives you, hey, this is the argument this function wants. So I want a new message. Hey, this is a new message. And then you see how the command is actually updating automatically, so it's like kind of a helper, right? And then what you do is you have GNOKey, which is the wallet, right? The wallet that we use just like MetaMask. And then I'm just gonna actually tell you what all of these are, just so you generally get the gist of it, right? What all of these little flags and this text really does. It's not that complicated, actually. You've probably learned about it already. Basically, it's going to make a transaction, right? Make TX, and then it's going to do a call to a function, right? It's kind of obvious. And then you give it a package path. So this is the thing that we were talking about before in the GNOME mod. So we're calling this application because it lives on this path, right? And then you're calling the update message function. And then you're giving it a gas fee and gas wanted. So this is something like the gas fee for MetaMask, right? All the blockchains have it. The send value is like the message value that you have in Ethereum. So it's like if you're sending some money with the transaction, you can do that. You're broadcasting it to the network. You're talking to this network that has a chain ID dev. So just like when you do, this is all hidden from you. That's the whole point. So the whole point of trying to teach you this, what all this stuff is, kind of looks complicated, right? It's kind of, why would I want to use this if I can just like click nice buttons and like it works, right? The point is that with this, you actually learn how it really works, even though it's a bit more complicated. But once you know this, then everything is easy peasy, right? So the idea is, okay, Gnoki, I'm using my wallet. It's going to make a transaction. It's going to call something. It's going to call something that lives on this specific path. It's going to call this function inside that specific path. It's going to give some, so UGNOT is the ETH of GNOland, okay? So it's like the coin that you use to pay gas, okay, UGNOT. U is, by the way, micro. So it's actually GNOT, and then UGNOT is like the millionth part of a GNOT. Okay, and then gas wanted. How many units of gas do you want to send? Broadcast is going to broadcast to the chain ID dev, and then it's going to give you the arguments that I parsed in here, okay? And then the final thing that it has is this remote. Remote is the actual connection that it's making to the blockchain node. So for example, if you check MetaMask, I don't want to open my MetaMask here, but point is, in MetaMask you can choose a network, and that network, when you choose it, it's basically like an IP address somewhere that MetaMask talks to. This is it, right? And then finally, this is the name of your key that you're going to use. So what you did in the beginning, you did no key add whatever, then you're using it in this case. So what I'm going to do is I'm going to copy this and paste it and click enter. And then just enter my password, which is in this case nothing, and I missed it, sorry. And it's going to say, okay, so I spent some gas, it was at this height, this is the hash of the transaction. Then if we go back to the main page, it's going to say, hey, this is a new message. Okay, so something happened. We updated, we made a transaction. Okay? Yes, no, good, bad, complicated? Yep.
This link for localhost access, is it the same for all of us? Because I cannot access it, like it doesn't exist.
Your local host doesn't exist?
Yeah, not found. Page doesn't exist.
No, not found. Okay, well, let me check it out. Are you talking to?
This link. And in Jupyter, no way.
Localhost? But it's Jupyter. You had the issue with the port, right? No?
With what?
No, it was you, sorry. You can set another port. In GNOdev, you can look at the help. So do GNOdev help, and then you can check the port, and then do another, because Jupyter is running on that port. You have to run on a different port, or turn off Jupyter, but okay. Right, has anybody managed to do this? No? Yes? Okay, do you want to have some more time? What is complex? Is there anything that I should explain a bit better or again? Sorry? You cannot go to this page? Is it this path? So it's localhost 8888. Okay, what does it say? Okay, let me go around. It's okay. Okay, so this is like the very basic application in GNU, all right? You had the init function, which was like the constructor, or you had the update message, which updates the message. It's an exported function. And you have this render function, which is basically what you've been seeing here the whole time. So render is like the view function in Solidity. You have the view keyword, and essentially it says that it doesn't do any state changes. Well, it can in this case. Render can do state changes, but the point of render is that it's like the default method that renders the state of your smart contract. So developers, when they write smart contracts in GNU, they say, hey, I want my smart contract to be displayed this way specifically, and then they define it in the render message, in the render function. Okay? So it's like a view function. Nothing, we don't have to stick around for this too much. Okay. Now, let's go into P2. So this is where we actually start building the code, the application. And then in this case, you can turn off GNU dev for P1, where you can go back out into P2. Okay, or rather, let me just go back in. So I'm in the top folder. What I can do is I can do GNU dev dot P2, right? So it's going to load the P2 code into the blockchain. Probably going to error, maybe not, we'll see. Not, okay, cool. But the point of this is you have this small README, and this is the part where you guys kind of take over with the code. So you run GNU dev, it can be in this folder, but point is you should run it in P2. And you should check the code comments in this twitter.gno file, and you have some to-do steps, okay? So the idea is try to write some GNU code, and I'll just show you what this looks like. So the idea is you have a small Twitter clone. It's very basic, but it has some top-level variables. It has a slice, so an array of pointers to posts, and the post is this structure, which you also have in Solidity, right? You have the structures. So it has an ID, it has text, it has an author, so whoever made the tweet or the post, and then it has a time at which it was created. And here you have the to-dos. So the idea is you're supposed to create a function to add a new post. So again, just remember, if you do, for example, this, add post, and then you define the logic here, this is going to be exported for anybody to call from the outside, right? Like it's a public function. So I'm going to give you some time now and just like try to type away at this. And GNU dev will probably be read at one point, because if, for example, I do something that's like illegal syntax, you see this is illegal syntax, it's going to say, hey, like something is wrong. Basically, you have a syntax error. So you don't have to look at it immediately, just look at it when you're kind of ready. So if I do this, and this is a valid function, it's empty, but it's valid. If I go back to GNU dev, it's going to say reloading, and everything is OK. Okay? So try to create a function to add a post, and try to create a function to remove a post. Okay? So the idea is add post is going to create a new post, and it's going to add it to this slice. So you have to figure out how to add things to the slice. And then remove post should take a ID, which will be able to, with it, you'll be able to actually find that specific post that you want to delete, and you'll be able to delete it. Okay? So just check this and see how it works. See if you can try to make these functions, and then I'll give you about 20 minutes and just type away. Okay? And like you can call me, and I'll come around and help you. Okay? All right, time is up. Let's check out the solution. I suggest you guys, if you can, just take this folder that you wrote your code in and just copy it somewhere outside of this. Just save it somewhere else, okay? Just save it to your desktop, or just copy paste it somewhere else, because I'm going to push some changes to the repository so you can pull the changes and see the solution. But you want to save your work. Okay? Just take out the whole P2 folder and just put it somewhere on desktop or whatever. All right, let's check out the solution. So most of you actually did it, which is great. So you would have like an add post function, which is like exported. It takes in a text. You can check if the text that was inputted was empty, so it's like a faulty transaction. And then in this case, you would panic. So this is something that I didn't really tell you yet, but just like in Solidity, you have this thing called revert or require, which is like a if, then revert. In GNU, you revert transactions by doing panic. So panic basically reverts all of the state changes that happened before this. So if there's like a grave error or something bad happened, basically the idea is that you'll be able to just discard all of the changes that happened thus far. Okay? Then I created this variable, which is an address or a pointer to a post struct that was created in memory. And some of you guys used something else here. It was std.getOrigeCaller, which is also fine. So this basically gives you the original signer to the transaction, while this is a bit of a different way of thinking about it. This is actually MSG sender, what I'm saying. So this is MSG sender, and this here is TX origin in Solidity. So basically the difference is TX origin always gives you the initial user account that signed the transaction, while message sender, or in this case prev_realm address, gives you the previous smart contract or previous address that called this one. Just a heads up, but both are fine. Both are perfectly fine in this case. And then time.now will return the block timestamp, which is good. And then you just append this to the post. You increment the counter, and here I just returned the ID just so the user has some feedback when he posts when they post a post, right? When they add a post. Okay, remove. I did the same thing here for the caller, so it's this, or it could have been std.getOriginCaller. That's also fine. And then I have this helper function, which is getPosts, which just iterates over the slice of posts and just gets this specific, the post with this specific ID. And then if it doesn't exist, it returns -1 and nil. And then in this case, if it's nil, I'm going to panic. So I'm just going to say, hey, something's wrong, just quit. And then if the author isn't the caller, so I just want to allow the person who created the post to delete the post. So if the caller isn't the author, I'm just going to panic. And then if everything else is fine, then take the slice of posts and just remove the post with this specific ID. So this takes the first X post up to IDX, up to index, and then appends. It skips one index and it appends the rest. So it basically just plops one out from the slice. Okay, cool. And then also here, if you take a look, this wasn't updated. This is you already have this in the code, but here you have like a receiver function. This is something that's specific to Go, but this is like defining a function on top of a structure. So this structure can have .string on it, right? And in this case, it's just returning the post in a specific format. It's going to be useful to you later. And then you have the render, which is basically the render that you're seeing on GNU Web. Okay, has everybody copied out their code? Is there anybody who didn't do it yet? Okay. You're going to lose. Yeah, copy it out. Copy it out. I might ask you to just give it to me later. But yeah, okay? All right, so now I'm going to give you P3, the third phase. So let me just quit this here, ls, yes, git reset hard head. Okay, and I'm going to add a new phase. So now we have a new phase, and I'm going to do git add P3, git push. Okay. So now I'll just give you a brief overview of what P3 should be. So P3 also has obviously some to-dos. You are supposed to add upvotes and downvotes to this existing stuff. So I pushed my code. You can do git pull, which is going to pull the changes that I just pushed. And it's going to give you the code that I just showed you. So this is like my implementation, right, with the functions that I just showed you. But you're supposed to add upvotes. And then you're supposed to add functions to upvote and downvote specific posts. Okay? And then you'll also be able to see that here there's also another to do. Just update this function to also show the upvotes and downvotes. Okay? Do you guys want a very quick break before we start this? Yes? Okay, let's do 7 minutes. No, because like until 55, okay? Yeah, okay. Okay, cool. Yeah, okay, so P3. I know you guys are a bit tired. I am as well. But let's try to finish this and maybe do another one of these. But if not, it's fine. But I do want to mention one thing. And I'll also have another short presentation in the evening. And it's about hackathons and how you can win them. So one of the really iconic things about hackathons is that they're very tiring, and that usually you don't sleep much, and you need to really push through some things, and some things can get messy. Code can not work sometimes. You can wreck your head against the wall sometimes. Just trying to figure something out is just not going to work. So it can be a bit painful. So try to power through this, and we'll see where we end up. But OK, so P3 is basically very short. You're supposed to add upvotes and downvotes to the post. I'll give you, how much time do you think you guys need? This is relatively simple. Maybe 10 minutes, 15? 10? OK, let's try to do 10, and then we'll see how you guys deal with it. OK? So P3. OK? So Go has ints and uints, so you can use those. Try those. So you can add values into the post struct, and then by default, just like in Solidity, when you define a field like this and you don't give it an explicit value, it's going to have its default value. And for all ints, it's just 0. And then you should add a function that's going to say upvote, downvote is going to be a public function, or they're going to be public functions, and they're going to take a post by an ID and upvote that specific, or downvote that specific ID if it exists. Okay, try it out. Okay, so I'm going to show you the solution, right? So the solution is relatively simple. Again, it was basically just adding 2 specific fields in this struct, upvotes, downvotes, and then I didn't really care if the person upvoted twice or not, and that's, it's not a feature really. It's a bug, so there should be some sort of check for this. So one person can only upvote one post once. So you could try to figure this out on your own. That was the bonus. But in order to not waste time, let's actually see. This is actually going to be the interesting part, I think. I mean, the interesting part. This is where we actually do something with like coins, and like, for example, in Solidity you have ETH. In this case, you have Hudak. So this is the native token of GNOland. The idea with this P4. So I'm just going to copy P4 over, just like last time, over here. Oh, sorry. OK, P4 is there. Is it there? Or is it? Oh, sorry. So I'm going to put it in here. There you go. And then I'm going to add P4. OK. So the idea is basically this. So you can pull the changes now. The idea is this. You want to be able to tip a post. So you want to be able to, if a post is really good, you want to be able to give it some money. In this case, give it some Hudak. So the idea is you need to figure out how to actually do this in GNO. I'm going to give you a couple of hints. GNO has something. So say Ethereum. Ethereum has Solidity, and in Solidity you have this message.value field, which gives you the Ethereum that was sent with the transaction. GNO is a bit more flexible, let's say, and GNO has this thing called a banker module. So it's basically like functionality that's built into the language, which allows you to create coins, send them, transfer them, burn them, issue them, do all of these things by default. So this kind of functionality doesn't really exist in Ethereum. It only exists in GNO. Because in Ethereum, you only have ETH, and that's it. And then you have to do the ERC20 tokens, and you have to do all these programmatic stuff, while in case of GNO, it's like built into the language. So STD, the package that I mentioned a couple of times. So I'm going to go to P4. One second. So I gave you a hint in this README. So basically, you run the same thing. You find the to-dos, and then check out the banker, check out coins, and check out this get orange send. This is like message value in Ethereum. So basically the idea is you can create a banker, you can initialize it, and then you can do banker.getCoins to be able to get coins of a specific address, and you'll be able to, because the post has an author, so somebody can tip a specific post and then send some coins along with the transaction, and then from there, the smart contract will directly or automatically forward the money to the author of the post. So what I also did was, in this case, I added like a total tips counter. So basically, like the post can track how many tips it actually gotten over time, but it's not actually gonna, like the smart contract isn't actually gonna store any value inside. So it's automatically going to forward it to the author. So again, you can pull the latest changes and just try out. This might be a bit difficult, but I'll be around to help, and this will be the last thing for today. So yeah, okay, that's it. Cool. So I will push this is like the final, quote unquote, this is not a challenge, this is the solution, I think. I forgot. But okay, so I will add this to phases. And here basically, yes, this is the solution. So the solution to this was essentially, so I created a tip total field here, which basically just counts the amounts of Hugnot that was sent to this specific post, but it's only for display purposes. It doesn't actually, like the post doesn't actually contain coins. It's just tracking the amount that passed through it, let's say. And then I have this tip post function. So first I get the coins sent with the transaction, with this function, and then I get the amount of specifically Hugnot because that's what I'm using for tips. Then the tip amount cannot be less than 0, so I just check that, and then panic if it is. I get the post in question, depending on the level of permission that the banker has. So you saw maybe that there's like only a read-only banker, there's a banker to issue coins, there's a banker to send some specific coins, and there's a banker to send all coins. The idea is basically that with those permissions, you can actually be very safe on when you use the banker because it's, you know, it handles money, so it needs to be safe. So the idea is basically realm send allows you to send any coins. This could have also been, for example, origin send. So origin send will only allow you to send the coins that were sent with the transaction, while realm send will allow you to send any coins from the realm balance, from the smart contract balance. So this would be safer than this, right? But okay, this will be safer than this, yes, okay. So the point is, then I create the actual instance of the coin that's going to be the tip. The amount is picked out at the beginning, and then I just get the current realm address, the current smart contract address, then I get the author from the post, and then I create a new coins slice because that's what this function takes. And I give it the actual instance of the coin. And then in the end, I just increment this just to keep track of what happened. And yeah, so some of you asked me, how do you actually test this? It's a good question. So if you do go to, let me see if so I'm gonna do gnodev final. I'm gonna load the final piece, right? And I'm gonna go here. Open this up, and then it was r/petnica/Twitter. And then in help, when you have the functions, right, let me actually do it. So I'll add new my post, okay. So I'll send 1. So I'll add a new post, that's cool. So the post is there, it has 0 upvotes, 0 downvotes, and 0 tips. And then I can go and try to tip it. So the ID is 0. And then here you have this send flag. Okay? So I will do this. I'll take this, and I'll actually change my address. So on the first one, I use this address. In this case, I'll use another address just to, in this code, we don't have a check against this because it's useless to try to tip your own post because you're just losing gas, right? You're just spending gas to do nothing. But in this case, let's make it make sense. And then basically I'll just say, okay, the amount that I'm sending will be 100 Hugnot. And then if I want to, I could also do this. I could say 100 Leon token, right? Whatever. Like you can specify more coins, and those coins are like the native banker coins. So if you can create a realm that uses the banker of the type issue coin, which is going to issue new coins for something. It's like natively in the language. So I do this, and then something happened. That's cool. And then I go back here, and there's 100 UNOT, and this is the author. So what I actually want to check is how do I actually check the real balance of this address? And this is also a good question. So it's Gnoki has a couple of things you can do. You can make transactions, but you can also query the chain. Querying the chain just means asking the chain, hey, can I just get some information? I don't want to change anything. I just want information, right? So just like calling a view function. In Ethereum, you also have it you have the option to send a transaction. You have the option to call. That's what it's called in Solidity or in Ethereum. And a call is simply a non-state changing transaction in Ethereum. While in this case, query is the same. And you can do bank/balances. This is the query type. And then you can give it this address that I want to check against. Whoops, sorry. What's going on? So I want this. Balances, and I give it the address. What the hell? Right, this. Okay. And then you see I have, so it had a lot of knots because the Gnode pre-mines them, but this 100 is actually the tip. So let me make this a little bit more clear. Let's say 1, 2, 3. And there you go, it's 2, 2, 3 now. So you can, this is actually verifying that the balance has actually changed. Okay, cool. That's basically the end. I will send you a link to the WhatsApp group. I just sent it. So just zip up your folder, if you can, like where you worked. Zip it up and just upload it to the Google Drive link that I sent. And if you can do it now, please do it now, because you're going to forget later. But yeah, that's the gist of it. You just learned, how to develop in GNU, like the basics. Hopefully, some of you guys liked it. Might have been a bit complicated, yes, but this is a project that's in development. So Ethereum has been existing for like 10 years now, and they've had a lot of time to battle test things. While, for example, GNU is only about 2 years old, maybe even less. So things are changing. The language is changing. Commands are changing. Tools are changing. Yeah. Okay, cool. That's it. Thank you.